It's Thursday, the 22nd of April. My name's Juan Brown. You're watching the Blanco Lirio channel. And on Tuesday, 20 April, the NTSB had a 3-hour-plus long board meeting discussing the final recommendations and probable cause of the tragic mid-air collision near Ketchikan, Alaska that occurred on 13 May of 2019 between the Taquan Air float plane Otter colliding with the Mountain Air Service float plane Beaver over the Misty Fjords near Ketchikan, Alaska, while conducting Part 135 sightseeing tours in clear VFR conditions. There's a lot to learn in this report. Let's dive into it. If you think the old FAA regulation of see and avoid in visual flight conditions is adequate to avoid mid-air collisions, you're sadly mistaken, and the accident record proves this. My involvement and passion for traffic collision avoidance goes way back. When I was in the 141s, after I got out of the 141s out of Travis Air Force Base, my co-pilot Peter Vallejo was lost in a tragic mid-air collision involving a C-141 transport aircraft and a German transport aircraft off the coast of Africa. Peter's family fought the U.S. Air Force and the whole entire military-industrial complex, along with many other folks, and finally, after that tragic mid-air collision, the Air Force finally adopted traffic collision avoidance systems into their military transport aircraft, long after the airlines had already adopted it. Soon after that, as I got involved with the air tanker industry, me and a handful of others fought hard to get TCAS equipment into the air tanker industry, and the industry fought that tooth and nail, as that's a very eyes outside of the cockpit sort of flying program. They didn't realize the benefits of TCAS until they eventually got it, and now they won't fly without it. And then finally, a couple of years ago, we witnessed a tragic mid-air collision at our own High Sierra fly-in event, where an aircraft flying a very non-standard pattern and not following the rules for the fly-in cut across all of the active runways and pattern and collided with another aircraft that was in the pattern, following the pattern correctly. Today, there are vast improvements in technology in general aviation that's helping us to deal with this traffic collision problem, but yet there are still some pretty serious limitations to this technology that we're just now learning about. Over the years, we've been tackling this problem with different levels of regulation, and in the airline industry, with the final implementation of TCAS, Traffic Collision Avoidance System, we have not experienced a single mid-air collision with an airliner since. What works in TCAS is the A in TCAS, the alerting system. It's a passive system that when a traffic collision becomes likely, the system wakes up and alerts you with an oral alert, traffic, directs your attention away from flying the aircraft for a moment to look at the screen, find out exactly where the imposing traffic is, and then turn your eyes outside to look for that traffic by alerting you. If that collision continues to narrow, the TCAS system will give you an RA, or a resolution advisory, and will literally tell you what you need to do to fly your aircraft away from the impending collision. In the airline industry at that point, because we're in a very busy congested airspace, we're normally flying the aircraft with the autopilot on. Once you get a resolution advisory, you click off the autopilot and you hand fly the directions given to you by the traffic collision avoidance system. In general aviation, after years of wrestling, we now have a requirement to have ADS-B out, or a traffic collision avoidance system that will transmit out our position, but not required in general aviation is something similar to these two items here, which most pilots are already using, that provides us ADS-B, or traffic collision avoidance information into the cockpit. This new technology for general aviation primarily came from the folks in Alaska. Flying in Alaska is considerably different, dealing with the weather and the close proximity to other aircraft. It's relatively crowded airspace in a non-radar environment in Alaska. So the program, the Capstone program, was developed to help develop technology that can improve aviation safety in Alaska. And that included synthetic aviation and traffic collision avoidance technology. That technology is what has trickled down to us here in general aviation today in the form of ADS-B. And as we know, studying accidents, each accident is a long series or a chain of events that where in the Swiss cheese model of accident prevention, the holes in the Swiss cheese just perfectly line up to allow the chain reaction or of events to happen to cause an accident. In the case of the TAC-1 midair, the holes were aligned by the thinnest of margins. A series of very unfortunate events came together to cause this midair. Basically, the Beaver aircraft is represented by my left hand, the Otter aircraft is represented by my right hand, and both aircraft were converging on a sightseeing waterfall ahead of them. Both aircraft had departed roughly the same location, took different routes, and then worked together. Well, they didn't work together, they ended up coming together, converging on a single waterfall sightseeing point. They were using common traffic advisories, but it's unclear if the last couple of radio calls were made as these two aircraft got closer and closer together. The Otter aircraft was descending, the Beaver aircraft was climbing slightly to level flight, and they came together as the Otter descended down upon the Beaver aircraft. See and avoid, the Beaver could not see the Otter out his right side because of the passenger in the right seat, his high wing configuration, and or the structure of the aircraft. Same thing with the Otter coming down onto the Beaver aircraft. Again, because of the structure of the aircraft in the Otter, he did not visually see that aircraft. Unfortunately, because of a couple of minor technical issues, the required traffic alerting system did not work. Today in general aviation, the old paper sectional charts have been replaced in favor with programs like ForeFlight that provide pilots flight planning, navigation, and traffic information along their route of flight. This traffic information is made possible by ADS-B in receivers like this Stratus unit. ForeFlight can also give you a traffic alert if in the event that you get too close to another aircraft. However, at the time of the accident in 2019, and I'm not sure if this is still true today, in order to receive a traffic alert on ForeFlight, the ADS-B in data needs to be provided from an aircraft with a pressure altitude recording and transmitting capability. Sadly, in the case of the TAC-1 Air, that particular piece of equipment, unknown to the pilot, was disabled. It was disabled 2 weeks earlier in maintenance, and nobody told anybody who was flying the aircraft that that piece of equipment was off, and the pilot did not notice that that particular piece of equipment was off. He was still receiving traffic information, but not the complete picture. So let's go and look at the animated recreation of this accident put together by the NTSB and see what happened.
A float equipped de Havilland DHC-2 Beaver and a float equipped de Havilland DHC-3 Otter collided in midair about 8 miles northeast of Ketchikan, Alaska. The Beaver and the Otter were conducting VFR Part 135 on-demand sightseeing flights. Both airplanes took off from the Misty Fjords National Monument about 30 miles northeast of Ketchikan and were headed to the Mahoney Lakes area near Ketchikan. The Beaver airplane, with a pilot and 4 passengers, departed about 12:02. The Otter airplane, with a pilot and 10 passengers, departed about a minute later. Calculated ground speeds and altitudes for both airplanes are displayed at the lower right, along with a clock that is displayed at the upper right of the animation. The airplanes collided at an altitude of about 3,350 feet near the west side of the George Inlet. Following the collision, the Otter turned about 180 degrees and descended into the waters of the George Inlet. 1 passenger on the Otter sustained fatal injuries. 9 passengers sustained serious injuries, and the pilot sustained minor injuries. The Beaver broke up in flight after the collision, and the debris was scattered over the terrain northeast of Mahoney Lake on the west shore of George Inlet. The pilot and all 4 passengers on board the Beaver sustained fatal injuries. The next series of animations depict the collision from both outside and inside the airplanes. This animation depicts an exterior view of the Otter looking towards the Beaver. The Beaver, in the white circle, becomes visible in the animation about 24 seconds before the collision. This animation depicts the view from the Otter pilot's seat, with cockpit structure obscuring portions of his field of view. About 11 seconds before the collision, our analysis concluded the Beaver would have been obscured behind the Otter's window post. The Otter pilot recalled seeing a flash, seeing white and red, and then a tremendous collision. This animation depicts an exterior view of the Beaver looking towards the Otter. The Otter, in the white circle, becomes visible in the animation about 30 seconds before the collision. Due to the airplane structure and the passenger seated to his right, it is unlikely the Beaver pilot could have seen the Otter prior to the collision. This animation depicts the view from a passenger seat on the right side of the Beaver. As the animation ends, the scene transitions to a photograph captured by a passenger's camera as the airplanes converged. The circle indicates the position of the Otter pilot, showing his view was obscured by the window post. The prevention of mid-air collisions has traditionally relied on pilots being able to see and avoid other aircraft. In this accident, the Otter pilot's view was obscured by the window post, and the Beaver pilot's view would have been blocked by airplane structure and his right seat passenger. The following animations depict simulated cockpit displays of traffic information for both airplanes starting about 4 minutes before the collision. Note that the actual range settings used on the displays during the accident flights are unknown. The displays on both airplanes are driven by NTSB data. The Beaver pilot had a 4-flight application on an Apple iPad display, and the Otter was equipped with a Chelton FlightLogic display. The 4-flight application on the Beaver pilot's iPad can provide oral and visual alerts of nearby traffic. However, it requires pressure altitude data from a target aircraft to generate an alert concerning that aircraft. The Otter was not broadcasting pressure altitude because a required piece of equipment was turned off. Consequently, the 4-flight application on the Beaver pilot's iPad could not produce an alert concerning the Otter. Additionally, Due to the lack of an alerting function contained within the ADS-B-in avionics that process traffic information, the Chelton display was not able to provide oral or visual alerts to draw the pilot's attention to traffic threats. The Otter's Chelton display presents a bird's eye view of the Otter, depicted as an airplane outline in the lower center of the display and the surrounding terrain and air traffic. Other aircraft are depicted as cyan arrowheads pointed in the direction they are flying. The arrowhead, representing the Beaver, appears at the Otter's 10 o'clock position and is filled with color because the Beaver is within a 6 nautical mile horizontal and a 1,200 foot vertical distance from the Otter. More distant aircraft are depicted as outlined, non-filled arrowheads. The numbers next to each arrowhead indicate each aircraft's altitude relative to the Otter in hundreds of feet. The iPad display on the Beaver, running the ForeFlight application, depicted the Beaver in the center as a blue aircraft silhouette. Other aircraft appear as filled cyan arrowheads, regardless of the distance from the Beaver. The arrowhead representing the Otter appears at the Beaver's 3 to 4 o'clock position with no relative altitude displayed because the Otter was not broadcasting pressure altitude. This simulation presents the oral and visual alerts that could have been generated by the ForeFlight application if the Otter had been broadcasting pressure altitude.
Traffic, 3 o'clock, 2 miles, 400 feet above.
Although both aircraft were equipped with traffic displays, limitations in the alerting capabilities resulted in neither pilot being alerted to the impending collision. Had these limitations not existed, oral and visual traffic alerts in each airplane would have occurred early enough for the pilots to have taken action to prevent the collision. As shown here, the ForeFlight application would have generated an alert 1 minute and 44 seconds before the collision. The actual time of an alert on the Chelton display is unknown, but based on similar systems, it is estimated that Chelton would have generated an alert 37.4 seconds before the collision.
After a comprehensive review of the circumstances that led to this accident, the investigation established that the following factors did not contribute to the cause: pilot qualifications, pilot medical conditions, and airplane mechanical malfunction or failure. Safety issues identified in this accident include the inherent limitations of the see and avoid concept, the safety benefits of ADS-B out and in supported traffic advisory systems, the lack of an ADS-B in requirement for Part 135, the absence of visual and oral alerts from the airplane's traffic display systems, the loss of pre-existing oral and visual alerting capability on capstone program aircraft, and the importance of accurate checklists. Staff has proposed recommendations in these areas and proposes reiterating a safety recommendation for safety management systems for Part 135 operators.
So because one important piece of equipment was disabled on the Otter aircraft during maintenance some 2 weeks prior, that piece of equipment that would have provided pressure altitude information to the ADS-B system, that was turned off. There was no traffic alert generated for either aircraft as these two aircraft got too close together. Now, according to the NTSB, they believe that had the Ketchikan Air had a conventional safety monitoring system or safety management system in place, that could have possibly prevented this gap in knowledge or the forgetting to tell the next guy down the line that this piece of equipment has been turned off, and or had Ketchikan had adequate checklists that reminds the pilot to make sure this particular piece of equipment is on and operating correctly, this accident may have been prevented. Thanks so much for your support of this channel. I hope this gives you a better understanding of what happened with the Ketchikan Air mid-air collision in Ketchikan, Alaska 2 years ago. See you here.